Lesson 14.5 is integral properties. So we're using the properties we talked about in lesson 4 to now apply it without a graph. Number 1 says, let f be a continuous function, which is always a criteria to be able to integrate it and find the area under the curves, such that from 2 to 0, that area is -1, and from 2 to 4, that area is 3. What is the value from 0 to 4 of f of x minus 1? So a couple things I want you to notice is, number 1, I don't like this starting with 2 and going to the 0. That's backwards to me. So I would fix it and say that the integral from 0 to 2 of f of x dx, remember you negate that, so now we're going to make that be actually +1. So that's number 1 problem I see. And then here I see that it is the function -1. So remember, that's taking something and then shifting it down 1. So it's going to create a rectangle that we have to find the area of, and it's going to subtract it away from what the net area originally was. But the other thing is thinking, okay, I'm going from 0 to 2. Then I can go from 2 to 4. And that will give me the area of 0 to 4. So it's like I'm connecting the dots, connecting the pieces. So that's another property we talked about. So that would be 1 plus the 3. That equals an area of 4. If we didn't have this, we'd be done. But now thinking of that rectangle, I know it's going to be 1 unit down. How long is it? Well, we can really just take the b minus the a, because we're going from 0, which I know this graph is not drawn right, but we're going from 0 to 4. That's going to be a width of 4. So our rectangle is 4 by -1. So we'd have 4 times -1. Well, that's -4. So actually, I'm going to net no area. Everything's going to cancel out. All right, number 2, we got another continuous function. -9 to 8, that area is 5. 4 to -9, again, I don't like how that looks, is -2. What is the value of 4 to 8 of 3 times f of x dx? So let's switch this real quick. And again, I don't think delta math will even do it, but to me it just bothers me. And it makes more sense in my brain. So this is actually going to turn into +2. Okay, so let's think here. On a number line, we would have -9, and we would have 4, and we would have 8, right? Least to greatest. And so let's think of what we've got here. -9 to 4, we just fixed it and said that area is 2 units, whatever our graph looks like. 4 to 8, we don't know. We're trying to solve for, so I'm going to call that x. But then we also know that -9 to 8 is an area of 5. So it creates this algebra problem where if I were to take 5 minus 2, that would leave me with 3. That's all we're really doing. So saying the area was 5 of the whole thing, minus this was 2, that leaves me with x being 3. But this property says take 3 times whatever the area from 4 to 8 was. So if my area from 4 to 8 is 3, I need to take 3 times 3, which is going to get me 9.